All right, guys, today we are moving on to section 2 of our chapter 1, talking about SI system and units for measure. So first off, we got to start with getting this definition of a standard. So a standard is an exact quantity that people agree to use for comparison. Big word here is comparison. We need to have standards so that two or more people can be able to communicate when we're talking about different measurements that we might make in science. The example I want to give you is using your hand to measure 3 tiles on the floor. If you are a taller person, you usually have larger hands, so these 3 tiles may only be 4 hands. However, if you are shorter in stature, usually you have smaller hands, and these 3 tiles may end up being 7 hands in length. This can lead to a big difference. If I was to say I needed a piece of carpet that measured 7 hands, okay, how big would it be for you? Okay, compare that to how big it might be for the person next to you. Definitely going to make a big difference. So this is why we have to have these standards. The other thing that we have to talk about is all measurements must have units. Okay, if you give me a number and you tell me it's 6, I don't know what this 6 is. Is this 6 cats, 6 dogs, 6 inches, 6 kilometers, 6 grams? I don't know. So you always have to make sure you give me your units. Okay, maybe it's 6 milliliters, but you have to include this unit. As we go throughout, I am going to be looking for in your data tables, whenever you give me a value, that it has the number and it has the unit. Both pieces are extremely important. Okay, so when we talk about measurement systems, we really have 3 different types. The first one is the English system. That's the one that we use here in the United States. Okay, your gallons, your inches, your feet, okay, pounds, all of those are examples of units that would be used in the English, or it's also known as the empirical system. Okay, the metric system is what's used by most of the world. If you go over to Europe, if you go down into Central and Southern America, they're going to be using the metric system. So if you go to get petrol, gasoline in your automobile, you are going to see the pump measure it in liters instead of gallons like we do here in the United States. Okay, mass is in grams. Okay, so we have really, for our sake, 3 main systems that main units that we're going to be talking about. We're talking about the gram, we are going to be talking about the meter, and we are going to be talking about the liter. And we'll get more into these later, but know that those are the 3 big ones that we have. Okay, so the SI system, which is used in science, okay, it stands for Système d'International, which is French, which is the improved version of the metric system. It's universally accepted worldwide. It's used and understood by scientists. So that means a scientist doing research here in Wisconsin can communicate with a scientist in Paris, France, who can communicate with a scientist in Tokyo, Japan. And that language is understood by all of it. So we don't have this confusion about how much did you give that human, or how much torque can something hold. Okay, based on multiples of 10. Each unit has a base unit and a standard unit. And again, those base units we just mentioned are our grams, our meters, and our liters. These big ones are the ones that we're going to talk about. There are many others though, but these are the 3 you are really going to want to know. Okay, more about these. SI prefixes, based on multiples of 10. Okay, you will need to have memorized for our class all the units between kilo and milli. Okay, as for right now, there are not 10 units for time, but what's great about time is you already know it. Seconds, minutes, hours. Okay, so when we are in this system, okay, we need to know how to convert between these units as well. So our prefixes are a nice little device to remember. King Hector died by drinking chocolate milk. Your units are kilo, hecto, deca. Your base unit, again, there's your meters, liters, and grams, deci, centi, and milli. For the most part, these are fairly easy to remember, and you can tell the abbreviations. The one that you have to be concerned with, which doesn't necessarily look like it all, is the deca. You will see this abbreviated DK. Other than that, they all make sense. So if we're in the meters, we're going to be kilometers, hectometers, decameters. Your base unit is just the meters. You get decimeters, it's just going to be a DM, centimeters, and then millimeters. Okay, that would be one example. If we're in grams, we've got kilograms, hectograms, decagrams, grams, decigrams, centigrams, milligrams. You could do this for a bunch of other different units as well. So let's practice doing the following conversions. I will help you with the first one, and then I'm going to have you guys take some time and do them yourself. So 96 milliliters to liters. Okay, we're just going to use by moving the decimals because it's nice and easy to do. So I always like to start writing my units, okay, up top. B here stands for base unit. Okay, again, kilo, hecto, deca, base, deci, centi, milli. So then I just like to find where I am starting. So I'm starting at milliliters. Okay, that's going to be right here at my M. And I am ending at liters. Okay, that's going to be my base unit. So then I simply figure out how many prefixes am I over. Okay, just count 1, 2, 3. So I know I need to move my decimal point 3 spots to the left. So if my number again is 96, where's my decimal originally? Okay, it's right here. If you don't see it, it's always at the end. So I'm going to move my decimal 3 spots to the left. 1, 2, 3. I have an empty spot. What is the only thing I can enter in? A 0. So I get my answer then, okay, as 0.096. Is my number done yet? No, because I have to put a unit. So I've got liters. Okay, I want you guys to take a few minutes and answer the next 3 by yourselves. Okay, and then there'll be a short couple questions here to answer when you are done. So go ahead and finish these and then answer the questions to continue. All right, so hopefully you are now understanding better how to convert within units. Now we need to understand which units do I use when I measure. Tomorrow's lab, you are going to have a ton of different objects throughout the classroom that you're going to simply have to measure. And you're going to have to make sure you are using the correct unit. So let's take a look at the different units and what we should use to measure them. Distance. If I was to measure distance here in the United States, what would I use? I might use inches, I might use feet, I might use yards, I might use miles. When it comes to distance in the SI system, the base here is meters. Okay, so you could have any of those prefixes that we had on the previous couple of slides in front of meters. So kilometers, that's going to be 1,000 meters. Hectometers, 100 meters. Decameters, 10 meters. If you just have meters, there's 1. Decimeters, 1/10 of a meter. Centimeter, 1/100th of a meter. And millimeter would be 1/1000th of a meter. Okay, volume. Volume is how much we have, okay, in the United States. Okay, think of volume, think of milk, think of gasoline, and we're talking, okay, our gallon, okay, or our pint, or our cup, okay. 2 cups equals a pint. How many pints are in a quart? How many quarts are in a gallon? It gets really confusing very fast because it's like 2, 4, 4, 8. Okay, I don't have it memorized. I have to use a little cheat sheet that is on my refrigerator when I am baking, which is maybe why I don't bake very often. However, if we used volume in the SI system, we are looking at the liters. Okay, with liters, the L is going to be capitalized. So if we have milliliters, it's going to be a lowercase m, capital L, and that's going to be 1/1000th of a liter. Okay, you could have your centiliters or your kiloliters, but the big common units are your milliliters and your liters. Okay, mass is how much space something takes up. For now, we're not going to worry about the common English unit. For mass, matter, for the SI unit, our base unit is our grams. Okay, so it's 1 unit of mass. The other big unit that we use here would be our kilogram. We don't use the other ones very often. Okay, 1 gram is about a paper clip. Just so you can get an idea. Okay. Matter, density. This is how much stuff is inside of a given space. Okay, so you can think of it as a little bit of a combination of our volume and our matter. These two things together help us get density. And there's a little formula that you're going to need to know. Density equals mass divided by volume. Okay, so if we have the mass of an object, if we have the volume of an object, we can figure out what its density is. So in the instance of a liquid, okay, our mass is in grams, our volume is in milliliters, or it could be grams per liter, because both of those are volume units. One thing I forgot to mention when we talked about volume is that these two units are used for liquids. If we are talking about a solid, okay, we have a different volume unit, and that volume unit is going to be centimeters cubed or meters cubed. Okay, big difference. Make sure that you have these down, because as you're going through lab tomorrow, you need to know, are you looking at a liquid or a solid? I think you should figure that out. That's going to determine whether you are using the milliliters, liters, or the solids for the centimeters cubed or meters cubed. One nice thing to convert, in case you ever get it wrong, 1 milliliter equals 1 centimeter cubed. So what's nice is we can just change the unit. Okay? The value, the number stays the same. Okay, moving on to time, this is the one that you already know. Okay, it is the same whether you are in the SI units or the English units. This is your seconds, your minutes, your hours, your days, etc. Okay, the final one that we have here is temperature. Okay, in English, we measure in degrees Fahrenheit. However, in science, I know what you're thinking. You're thinking it's going to be degrees Celsius, right? Okay, not entirely correct. Okay, the actual units for temperature is Kelvin. Okay, which is abbreviated K. Okay, Kelvin is the SI unit for temperature. It has to do with absolute zero, which we will get into second semester of what absolute zero is and why 0 Kelvin is known as that and what really happens about that. When we talk about solids, liquids, and gases in more detail, we'll get to that. Okay, however, in science, most of the time we report temperature in that degrees Celsius. However, there's a lot of times where we need to convert, which is real easy. There's this magic number. Okay, let me clear off my screen here for you guys. Went a little far, so just bear with me while I get to where I need to be again. All right, back to where we need to be. Let's talk some more about the converting between Kelvin and Celsius. The magic number here is 273. Okay, I cannot have a negative Kelvin. So if I have a degrees Celsius, okay, I'm going to add 273 to that to get the Kelvin. If I have a Kelvin temperature, I am going to subtract 273 to get the degrees Celsius. Okay, just remember the magic number of 273 and that I cannot have a negative Kelvin. Does not exist. Okay, one last topic that we have to talk about is these two vocabulary words of accuracy and precision. Accuracy is how close your measurements are to the real or accepted value of whatever you are measuring. Okay, that is if I know something masses 100 grams and I put it on the balance to mass it, and I am getting 99.9 grams and 100.1 grams and maybe even 99.8 grams. Okay, I am measuring accurately because I am very, very, very close to what it's supposed to mass at, that 100 grams. Precision is how close your measurements are to one another. Okay, this is me putting that same 100 gram mass on, but now instead of it massing 100 grams, maybe I'm massing it at 97.2 and 97.2 and 97.3. I'm not very close to that accepted value, but my measurements are very close together. So which one is more important? Okay, you can have one without the other. I can be accurate without being precise. Maybe I only measure it once. Maybe I can be precise without being accurate, as the example I gave you. Okay, we want both. we want you to be accurate and we want you to be precise. So you should measure things more than once. Okay, this will help you make sure that you are precise and it'll make sure that you're accurate as well. The thing is you can only be as accurate and precise as the tool you are using. Okay, if I am trying to measure a small amount of water, I'm going to want a graduated cylinder that is very small and has a lot of marks that are going to make that small measurement easier to make. If I pour it into a big giant beaker, okay, think of a 2-liter bottle, okay, my small measurement is not going to come out. Okay, so I want to use the best tool for the job. So as we're thinking about accuracy and precision, one way to think about it is a dartboard, okay, an archery target. So the first thing is, okay, what would this be? Would this be accurate? Would this be precise? Would this be neither? Or would this be both? Okay, what about this one? Okay, what about here? And this one. All right, once you are done taking notes, okay, and you've answered all the questions, make sure you go on Skyward and do your lab entry ticket for tomorrow. Okay, that's going to be lab entry ticket 1.2. Make sure that you set up your lab notebook. Okay, with lab 1.2. Remember that can be found on Schoology. Okay, and make sure to remember that you can use your lab to help you with that lab entry ticket. Please don't guess on the answers. Make sure you have that lab right in front of you as you are doing the questions on Skyward. If you have any questions, let me know. I am here to help you. And that is notes for the day.